All right. In this video today, we're looking at the general solutions for trig equations. In the last video, we did like specific solutions. Like we were given a domain for x, and you only had like a certain number of solutions. But sometimes you're not given a domain for x, and you have to write down all the solutions. And because trig functions go on forever and ever and ever, in other words, if I drew the sine functions, for instance, it just goes on forever. And you're saying, well, where is sine equal to a half? It's equal to a half there, and there, and there, and there, and there, and there. It's infinite. There's infinite different places where that solution is true. Okay. And so we need to think of a way to be able to write down an infinite number of solutions. And so I should have left that up on the thing. But if you remember the period of sine is equal to 2 pi. So all of your solutions are 2 pi apart. The period of cos is also 2 pi, but the period of tan is a bit different. If you remember, the period is just pi. And so all the solutions will always be 2 pi apart for sine and cos and 1 pi apart for tan. If you just keep that in mind, I'll keep that box there. As we sort of go through, that will sort of help you. Okay, so let's have a look at this first equation. So exactly like we solved before, we just want to have tan by itself. So let's have tan x equals, move the 1 to the other side to become -1, and then divide by √3. So we get -1 on √3 for tan x. Okay. Then we draw our circle. Where is tan equal to -1 on √3? So it's equal to 1 on √3 there, okay? But we want -1 on √3, and so that's going to happen there, okay? Sorry, my brain just exploded. And also there, okay? So just to make it clear which ones, there, not there, because that was the +1 on √3, okay? So they're the positions where tan is equal to 1 on √3. All good. So now that we've got those, we need to write down a general solution. We need to write down all of those because if you think about it, if we start at 0 and we go up, we get a solution there, and then we go around, we get a solution there, and we keep going, then we get a solution there, 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 etc., etc., etc. We're going to get infinite solutions as we go around, okay? So how do we write that down? So with tan, because they're all pi apart, we can just start at one of them, just choose one of the solutions and then go, well, it's going to be that one, right? So let's just write that down. So I'll do that now. And so therefore, x is equal to, let's write down that first one, which is 5 pi on 6. That's that first one right there. Just change it to green. 5 pi on 6. And where's the next solution? Well, the next solution will be another pi along, okay? And then where's the one after that? Well, it's going to be another pi along. And they're all going to be pi apart. And so instead of writing them all down, I'm not going to write an infinite number of solutions down. What we can just say is we can say plus k pi, where k is an integer, right? And what does that mean? Well, k is an integer. What are the integers? Integers are whole numbers. So -3, -2, -1, 0, 1, 2, 3, all the whole numbers. And so that means we're just adding a whole number multiple of pi. So it's 5 pi and 6 plus 1 pi, plus 2 pi, plus 3 pi, plus 4 pi, etc., 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 up into infinity. So that's how we write down the general solution to encompass all of the different possible solutions. Now, that you could leave the answer exactly like that. That's done. We can do that. If you want to put it all over a fraction, which you need to do in the next sort of question, so I'll show you this anyway now, I could put it all over 6. And so then it would be 5 pi on 6 for there. But then if I times the k pi by 6 as well, so that would be 6k pi if I wanted to put it all over the same fraction. And then you can take out pi's and things like that. And so if we took out pi on 6 out the front, what would be left inside? It'd be 5 plus 6k. And so that's another way that you could write the solution to this equation as well. Okay. Sometimes that's preferred, sometimes it doesn't matter, but you'll see in the next one, it's actually preferable. It's much easier if you write it like that, but they both mean the same thing. So just to reiterate, that is a good solution. that is a good solution too. It just might be that one is better than the other in certain situations, but they are both correct. Okay, so that's the general solution to that equation. Let's have a look at another one. Let's do cos, right? So let's remember the period of cos is 2 pi. So let's have a think about this. First step, you know what it is. We need to rearrange. And so we're going to have cos 3x is equal to, I'm going to move that root 2 to the other side and then divide by 2. Okay, so cos 3x is equal to negative root 2 on 2. Let's draw our circle. Where is cos equal to root 2 on 2? Cos is equal to root 2 on 2 there, but we want negative root 2 on 2, so remember cos is x, and so that's going to be there and there. Just to make it clear, that one and not that one. Okay, so there my cos 3x is there. Okay, so my next line is writing down the following. Okay, so therefore 3x is equal to, what are those angles? That first one, that's 3 pi over 4, all right? So let's just slow this down a bit. So if we start at 0 and we come around, there's my first solution at 3 pi on 4. Just ignore this guy for now. I'm only going to worry about the 3 pi on 4 because this one's a little bit harder than the tan. And so 3 pi on 4 is my first solution. Where does my next solution come up just for this one? If I go around, I get back to 2 pi, and then I keep going, and then I hit another solution there. And so that 3 pi on 4, the next solution in that spot is going to be, what the heck, I'll leave it in red, 2k pi apart, okay, where k is an integer. And so they're going to be 2 pi apart. So if k is 1, that's another 2 pi on. If k is 2, it's going to be 4 pi, 6 pi, 8 pi. That's all the solutions that are going to be all the way around. And I'm going to get rid of that because I should just press the delete thing. I don't do this the best way quite often. Okay, plus 2k pi. Okay, so that's that first one. But there's another set of solutions because there's still this guy that we haven't thought about yet. So let's do that. So I'm going to write down or 3x is equal to, and let's do the other solution. That is 5 pi on 4. And because cos has a period of 2 pi, it's also going to be 2k pi. So all you need to remember is that whenever you're solving for cos or sine, you're going to put plus 2k pi. Whenever you're solving for tan, they're going to be plus k pi. Okay, and so we've got those two as our solutions. Okay, so that is that. But we need to make this solution look a bit nicer, okay? Like I said in the last example, we've got this and it's sort of a little bit messy. We've also got that 3x. We want to divide by 3. It's going to look horrible. And so we're just going to sort of consolidate these answers a little bit. So 3x is equal to, I'm just going to do the top line. I'm going to put it all into one fraction. So I'm going to put everything over 4. So it's going to 3 pi over 4 plus, we're going to put that over 4, I need to times the top line by 4. So that's going to be 8k pi. Okay. I'm just going to write them next to each other. I prefer writing it like this. 3x is equal to, and I'm going to put these over 4 as well. And so it's going to be 5 pi on 4. Plus, and I'm going to times that by 4 as well, 8k pi. So just using sort of adding fractions sort of thing. All good. And now what I'm going to do, just to finish it off, I'm going to divide both sides by 3. So therefore, x is equal to 3 pi plus 8k pi over 12. I've divided both sides by 3. Or x equals, do the same thing, 5 pi plus 8k pi over 12. All right. And like I did in the last example, I prefer to write it like this, and you sort of get the point. But what I'm going to write that is I'm going to put pi, I'm going to take pi on 12 out the front. So pi over 12. And I'm just going to have 3 plus 8k on the inside. And I just think that's a much nicer way to write it. It's much clearer, and if you're looking for solutions later on, it actually becomes easy as well. Or x equals, I'm going to take out the pi on 12 out the front here as well. You'll notice that they're always the same. always the same numbers that you're pulling out, and then 5 plus 8k. And don't forget to let the examiner know what you mean by k. K is an integer. And so that is the actual solution for this one. That's the general solution to this equation. There's infinite solutions, and they all have that form. For any k, any whole number k, they will be the solutions. Hope that makes sense. I'll see you in the next video.